So for this video, I'm going to assume that you either know how to do problem 16 or you watched that video, because some of the stuff that happens in here is what I covered in the previous video on 16. So if not, go back, watch that video, and then come on back to 17. So find the z-scores that bound the middle 58% of the area under the standard normal curve. So let's draw standard normal curve. That wasn't my best effort, but whatever. So here's my mean, z equals 0 right there in the middle. These are z-scores, remember? So we're talking about the middle 58. So let's kind of section off the middle 58 here. And we're saying that this is 58%. That's 58% of the area under the entire curve. So if this is 58%, right? The stuff that's left, that's 100% minus 58%. That's 42% is left over. Now, it might not look like it because of my drawing, but this is symmetric. And the reason why I'm doing this is some tables will give you the area from the mean, from 0, to some other z value, right? Some tables give you that. The tables you're using on your exam give you the area to the left, right? Remember that? So these tables here give you the area to the left of your z value, whether negative z value or positive z value. It gives you the area to the left, right? So the reason why I'm doing this kind of analysis is because I really want to target this area here, because I know I can go to the table and figure this out, find this z value here, right? This negative z value. And since this curve is symmetric, that negative z value, change the sign, I'll have this positive z value. Because if 42% is left over, that means each one of these should be 21%. 42 divided by 2. So each one of these areas here, these regions, is 21% of the area under the curve. All of this adds up to 100%. 42 plus 58 is 100%. When I go to the table, I'm interested in this area here, the area to the left. Now, if I change that percent to a decimal, divide by 100, or move the decimal point 2 places to the left, this is 0.21. This area here is 0.21. This area is 0.21, and I want to figure out this z value. I want to determine that z value. So again, this area is 0.21, right? When I go back to my table, the table gives me the area. All these numbers here represent the area under the curve, the area. So what I'm doing is I'm looking here in the body of this table for the area for my 0.21, right? For my 0.21, this area here. I'm looking in the body of the table for 0.21, and then that'll help me determine the z value that gives me that area. I might not get exactly 0.21, but I want to get as close as possible to 0.21. As close as is possible. So I'm searching through these values here. I've got 0.209. I've got 0.2119. Which one of these is closer? This is 100th away. This is 1900ths away, right? Right, from 0.21. If I add 0.001, I get 0.21. If I subtract 0.0019, did I say 100th? I meant this is 1,000th away. And this is more than 1,000th away. So this is the one I want to use. This is closer to 0.21. Closer to 0.21. So that's z value that gives me this area. is negative 0.081. Negative 0.81. Okay, so let me go back here. So that z-value is negative 0.81. And on the positive side, since this table is this curve is symmetric, it's going to be positive 0.81, this z-value here. And those are my z-values. Z equals negative 0.81 and also positive 0.81.